So we'll do another example. Example 2. On bijectivity of a quadratic function. Okay, so let me start with the questions, yes? Who's the first one to ask? Questions?
I have a question. On the previous example, when plotting the graph, I was logged out. How did we come up with the x values?
So we didn't get the intercept though. We just got the turning point. Well, that's the point.
So we just estimated that one is positive and the other one is negative.
Yeah, using the y-intercept, because the y-intercept was below the x-axis, so meaning that it would cut the x-axis on the other side.
Why? Oh, okay. Thank you, sir.
Okay. Let me go to Joseph. Joseph or Mono.
Sir, I'm getting confused on why we're using completing the square method to find the values of x.
So that's like, okay. Let me answer this one as we do this question here. Moses.
Okay.
Sir.
Yes.
I didn't see how you got the -1/3.
-1/3. Okay. So it has to do with the completing the square. Look at this one. We do a full quadratic question here, not just a minor. Let me get a full one. Okay. Let me not avoid it. I've seen it in so many exams, so let me just get it as it is. This one. So here we have lost the previous page. So in a new meeting. So f of x is equal to x squared minus x. And then we are supposed to check if this function is bijective. If the function is bijective. So now we are saying to check if the function is bijective, we check if the function is 1-to-1. But as we understand, it's a quadratic, so it's not 1-to-1. Okay, it's to the power 2, so it's not 1-to-1. But suppose you don't know, and you can't use that just to say because the quadratic is not 1-to-1. You check. So you say if f of a is equal to f of b, then we'll have a squared minus a is equal to b squared minus b. This is the reason why we use completing the square. Because, wow, we can't get the value of a here. If I say I factor out a, then I'll have a minus 1. I factor out b, then I have b minus 1. This is not true. Because this will tell me that either a is equal to b or a minus 1 is equal to b minus 1. If that is the case, then this will also say a is equal to b, which is not true. So to solve for a and b here, we actually complete the square so that we just have one a and one b appearing either side. And then we are able, when we square root, if it means square rooting, we can get the value of a single value of a. Does somebody else see the screen? I'll share. Okay, I hope you can see now. Okay, so to do that, how do you complete the square now? How do we complete the square now? Still, or you were commenting on? So please make sure that you're able to see the board. You should be able to see now. If you can't see, then check your network. I think now it's your network. Okay, then here we complete the square of this function, a squared minus a. But because it's the same thing on the right, b squared minus b, whatever I do on the left, I will just be copying on the right, but I'll be copying using b. So on the left, you say, since the coefficient of a squared is already 1, so we'll just move to the coefficient of a, which is -1. Write it like this first, and then add as we divide -1 by 2, and then square it. Then subtract the same -1 over 2 squared. This is on the left. We do the same on the right. B squared minus b plus -1 over 2 squared minus -1 over 2 squared. So to complete the square, you make sure that the coefficient of the squared variable is 1, and then divide the coefficient of the variable that is not squared by 2. That number you get, you add it as a square and subtract the same value. Okay, then you now put these three together, you get a, and pick this one in the brackets as it is. It is -half. So write it just like that, and square. Ignore the middle part, and then just write this one as it is. So it is minus, but -1 over 2, when you square it, it becomes +1 over 4. On the right, we'll do the same. Pick these three and put them in the brackets, b -half. As you ignore the middle one, and then minus, when you square negative, you get positive, this one. Okay, then now we are saying this and this one will cancel. Then we will remain with a -half squared is equal to b -half squared. Then we square root now. We square root now. We will get a -1 over 2 is equal to plus or minus b -1 over 2. This means that the value of a is +1 over 2 plus or minus b -1 over 2. Well, even if we don't solve a completely, in this case, all we get is that f is not 1-to-1. Okay, f is not 1-to-1. Because f is not 1-to-1, because f is not 1-to-1, we are saying f is actually not bijective. Okay, I can take questions now. I've seen those who had questions, please put up your hands again so we can go one by one. Okay. So I'll see you when you come back. So hence f is not bijective. We now want to make f bijective. What do we do? We'll get back to the original f and say our function f is actually x squared minus x. We complete the square of this function. Okay? Why am I saying complete the square? Because we have already done the completing here. So I'll just copy. I'll say x minus half squared minus 1 over 4. From there now, we get the turning point. We get the turning point. The turning point is positive half now, comma negative 1 over 4. Please, I comment here. How do you get the turning point after completing the square? You equate the inside x minus half. You equate it to 0, and so for x, so it will always be the opposite sign. X is positive half because it was negative inside the bracket. And then pick the other one as it is with its negative, if it has a negative, as the y coordinate. Okay? When you do that, you now have the turning point. Joseph, your hand is up. Please ask if it's a question. Hello? I can get it. Just as you wait for internet to stabilize, maybe you can get a question. Yes?
Sorry, but please, can you explain again when finding the turning point?
Yeah. So
Okay, I get you.
Hudson.
Okay, how do you get the turning point? When getting the turning point, you go in the brackets first after you completed the square and get the whole thing inside the brackets and equate it to 0. Inside the bracket, we have x minus 1 over 2. So I get it here and equate it to 0. So for x, the x value I get becomes the x coordinate of the turning point. The x coordinate of the turning point. The number standing outside the bracket, this number here, is the y coordinate, of the turning point. This number here is the y coordinate of the turning point. So we have the x coordinate and the y coordinate to form the full turning point. Now, when I get the purpose is to make the function bijective. That is the main purpose. We want to make the function bijective. So what we do is we pick this number and say, let now the domain of f be equal to x, a real number, such that x is greater or equal to 1 over 2. First thing. Then the range is going to be y, a real number. Sarah?
On the part for finding the domain, since you said you can choose either side, so can it also be x less than or equal to half?
Yes. So it can
Alright, thank
also
you.
be, so here you say, or you don't write both of them at the same time. So you can also use x less or equal to half. It does not matter. But don't put both of them. You say this or this. That one becomes union. You lose marks. Okay, so that's why I'll just write 1. And you can make a decision right now to say, I'll be using the positive one, or I'll be using the negative one. Then for the range, you say y a real number such that y is greater or equal to negative 1 over 4. Hello.
Sorry, you are cutting, so I didn't get on how you answered the DF.
Okay, so
Is it just to get that one thing?
You just get this greater or equal to half. You can also choose to get the less or equal to half. It's one and the same thing. What you don't need is to see both of them. So you just pick one.
Thank you.
Okay. So this domain is not for the original f. This domain is for the f so that it becomes bijective. So this domain here is to make f bijective. Okay. So to make f a bijective, you restrict the domain, and this is the restricted domain. The range did not change. Now they will ask, after you've made f bijective, it means that now f has an inverse. So find the inverse. How do you just stop seeing what I'm writing? Don't stop. Then they say, find the inverse. Inverse of f, now that f is bijective. So f of x is x squared minus x. We now want to find the inverse. So we say, let y be x squared minus x. To find x, to make x the subject, you've seen that it needs completing the square. But the good news is that we've already done the completing the square. See, it is sitting here. So it's here, x minus 1 over 2 squared minus 1 over 4. So this is x minus 1 over 2 squared minus 1 over 4. Then we take this the other side. So we have y plus 1 over 4 is equal to x minus 1 over 2 squared. Then we square root. So we'll get x minus 1 over 2 is equal to plus or minus the square root of y plus 1 over 4. Take this the other side. So we'll have x is equal to positive 1 over 2 plus or minus the root y plus 1 over 4. So that we have f inverse of x to be equal to 1 over 2 plus or minus y. So now I'll put the inverse, so I'll put x. So x plus 1 over 4. The reason why we restricted the domain was to remove this plus or minus. This one. This is the main reason why we had to restrict the domain. So now we'll say, therefore, our inverse is going to be half plus the root of x plus 1 over 4. Because I picked the greater or equal to 1 here. So this is how it becomes funny. If I pick the less or equal to, then I was supposed to pick the minus. If I pick the greater or equal to, then I pick the plus. So this is the inverse. This function has an inverse now because we have made it bijective. Initially, it did not have the inverse. What it had was, it was just giving us an idea to say, well, the inverse might be there. It could be positive or minus. And that's not the inverse. It has to be well decided. And that's how we make the function bijective. If it was not bijective. So interesting. Okay. We go to example 3, where we'll talk about how to sketch f of x is equal to.
Sir, can you revisit the previous page? I want to screenshot. Okay, thank you, sir.
Okay. So x minus 1 plus x plus 3. Sketch this function. So we'll answer it as if it's been asked in the form of redefine and sketch. Redefine and then sketch. So we'll start by redefining. So step 1 in the sketching is to redefine. Redefine f of x. To redefine, we first redefine the pieces. So we know that x minus 1 in the modulus is the same thing as x minus 1 outside the modulus if x minus 1 is greater or equal to.
You can just see it.
Sarang, your hand is still up. Oh, you didn't put it down that there.
No, I didn't put it down.
Okay, okay. This same x minus 1 is equal to negative x minus 1 if x minus 1 is less than 0. This means that the modulus of x minus 1 is actually x minus 1 if x is greater or equal to positive 1. It is negative x plus 1 if x is less than 1. Please note that the negative does not reach this part. The negative ends here. Okay, so we call this the first one. The second one is the modulus of x plus 3 outside the modulus is the same thing as x plus 3, provided x plus 3 is greater or equal to 0. It is negative x plus 3, provided x plus 3 is less than 0. So that x plus 3 becomes x plus 3 when x is greater or equal to the negative of 3, and negative x minus 3 when x is less than the negative 3. Look at f. F is the sum of these two pieces. So to get to f, we form a table. So we form a table 1. So I'll start the smallest number in the table, negative 3. So I put negative 3 here. Joseph, your hand is up. Please ask if it's a question. Okay, then I also pick 1. Then I draw a table. Demarcated in this one.
Sir.
Hello.
Yes, sir. On the part, I thought you said negative isn't supposed to reach on the second part. Wasn't supposed to be negative x plus 3?
No. The negative ends here. It does not reach the less part. So the negative ends here and not this side. Okay. So now, this interval here is for x less than negative 3. This is for negative 3 less or equal to x less than 1. And this is for x greater or equal to 1. Then we have the pieces. So we have the pieces. The pieces are the first piece is the modulus of x minus 1. The second piece is the modulus of x plus 3. And the third piece will be the function f of x. So what is the modulus of x minus 1 when x is less than negative 3? If you have a number line, negative 3 is here and 1 is here. When x is less than, so if x is somewhere here, suppose x is negative 4, this number is less than negative 3. So there is no doubt that this number is less than 1. So automatically, negative 4 is less than negative 3, but negative 3 is less than 1, implying that negative 4 is less than 1. So it means that where we see negative 3, x less than negative 3, it's the same thing as seeing x less than 1. So we'll have x, so we'll have this one, minus x plus 1. And again, in the middle, x is now less than 1 directly. So we still get negative x plus 1. Then when x is greater or equal to 1, we get x minus 1. We got x plus 3. When x is less than negative 3, we get negative x minus 3. Salam?
Can you kindly repeat on getting the values? You start from where you pick the value for x less than negative 3.
So when you are picking the values, here you won't necessarily have to pick the actual numbers. You just want to have an understanding that since I have inequalities x less than negative 3, I also have negative 3 less or equal to x, which is less than 1. And I also have x greater or equal to 1. The understanding is you want to see what this becomes as you go through those inequalities. What does x minus 1 become when x is less than negative 3? So you understand that if x is less than negative 3, so you understand that when x is less than negative 3, it's automatically the fact that x will be less than. So whenever x is less than negative 3, there's no doubt that x is less than 1. Because anything that is less than negative 3 is less than 1. Because negative 3 itself is less than 1. So we are saying in the interval where x is less than negative 3, x minus 1 will be defined using x less than 1. In the interval where x is less than 1 but bigger than negative 3, this function will still be defined as x less than 1. And then x greater or equal to 1 will now move to its actual x greater or equal to 1. The same thing will happen to x plus 3. So here we'll have, here now we'll have x plus 3 itself, because we are talking of x being greater or equal to negative 3. And then when x is bigger than 1, automatically x is bigger than negative 3. Answer?
Can you please repeat from the beginning, from x minus 1, the first set of intervals?
So from x minus 1 here, from x minus 1, here we are saying we want to use these two to fill in these gaps here. So because we are using these two, and we have 3 inequalities, now we are saying the inequality I have is x less than negative 3. Where does this fall in between x less than 1 and x greater than 1? Can we say x less than negative 3 is where it's found when x is bigger than 1? That would be not true, because negative 3 is not bigger than 1. So we'll go for x less than 1, because when x is less than 1, well, it's okay to think of it being less than negative 3. If we are even told that x is less than negative 3, then it becomes a must that x is less than 1. So in between this one and this piece, when x is less than negative 3, we pick negative x plus 1. We put it here. When x is less than 1, x is less than 1. So we still pick the same negative x plus 1. When x is greater or equal to 1, we pick x greater or equal to 1. So we put it here. Then we go to x plus 3. When x is less than negative 3, when x is less than negative 3, we have negative x plus 3. So we put it here. When x is greater than negative 3, when x is greater than negative 3, we have x plus 3. So we put x plus 3. When x is greater than 1, it is when x is greater than negative 3. So we still have x plus 3 here. Then now to get f of x, you get the sum of this one and this one in each column. So add, say, okay, so what is negative x plus negative x? Here we get negative 2x. 1 plus -3, we get -2. Negative x plus x, we get 0. 1 plus 3, we get 4. X plus x, we get 2x. Minus 1 plus 3, we get 2. So the function has been redefined. Okay, so we have redefined the function as f of x is equal to 3 pieces -2x minus 2 when x is less than -3. We have also redefined as +4 when -3 is less or equal to x but less than 1, and +2x plus 2 when x is greater or equal to +1. That's how we redefine the function. So it will be cutting very soon. We quickly rejoin so that we can now sketch this function.
Sir, logged out. Is this
This is what we've done. But we are rejoining very soon because it will be cutting. Natasha, you ask once we rejoin.